Fischer's studies of glucose structure. Fischer's structural studies. Of glucose. The spatial arrangement of hydroxyl units was studied. Exact spatial arrangement of OH groups. So based on that, we can have the gluconic acid and the saccharic acid. COOH, CHOH, COH, H, and then COH, H, 1, 2, 3, 4, 5, 6, OH. So this is called the gluconic acid. This is known as gluconic acid. And this structure can be simply represented as COOH. We can simply put HOH, OH, H, and then OH, OH, H, OH. So 1, 2, 3, 4, 5, CH2OH. So this is gluconic acid. It is a monocarboxylic acid. So he was able to establish the structure for this. Similarly for the dicarboxylic acid also. So this CH2OH is converted into carboxylic acid. So we can declare the structure of dicarboxylic acid. So 1, 2, remaining 1, 2, 3, 4. In fact, this is first carbon atom, second carbon atom, third carbon atom, and the fourth carbon atom hydroxyl group is on the left side. The remaining are on the right side. Done. So this is a dicarboxylic acid, and what do you call this acid? Saccharic acid. SACCHARAC. So what do you call the saccharic acid? Is a dicarboxylic acid because it has got two COOH group. So from this, Fischer was able to derive the structure. He was able to confirm the spatial arrangement of this structure. So as we know, we can put like this for glucose. This is CH2OH and the terminal is CHO. In between that you have got 4 carbon atom. 1, 2, 3, 4. 1, 2, 3, 4th carbon atom hydroxyl unit on the left side and the remaining are on the right side. Done. So this is the structure of glucose. Actually, this glucose is correctly named as D plus glucose. D plus glucose. So this D represents the configuration and plus represents the dextrorotatory nature. Are you able to follow? So D represents the configuration. And plus means dextrorotatory. DX, DEX, X, TRO, rotatory. That is on the right side. It rotates the optical activity is on the right side. Whereas this D has nothing to do with the optical rotation. Okay. We can call it D notation or L notation. Actually, this D and L notation before the name of any compound indicates the relative configuration of a particular stereoisomer. Stereo means space. So space-wise, when a molecule has a different orientation, they can be called a stereoisomer. For example, let us consider glyceroldehyde. CHO, CHOH, CH2OH. So that is called glyceroldehyde. Glyceroldehyde. And it can be simply represented as, this is CH2OH, this is CHO. In between that you have H and OH. Now this is the first carbon atom and we go to the next carbon atom. This is the primary alcoholic group and this is the secondary alcoholic group. So based on the position of the second carbon atom, that is the hydroxyl group attached to the second carbon atom, it is named as D-glyceroldehyde or L-glyceroldehyde. D-glyceroldehyde means that is the hydroxyl group is on the right side. So this can be called D-glyceroldehyde. And similarly, we have L-glyceroldehyde. Now let me write both structures on the same side so that you can understand better. Do you understand? So OH on the left side. So if the OH is present on the left side, then it's called, that is L, because it's optical. In this case it is minus glyceroldehyde. You can call it minus glyceroldehyde. And this is on the right side, so plus glyceroldehyde. Okay. So the isomer, plus isomer of glyceroldehyde has deconfiguration. This is called deconfiguration. It means the structural formula is written on the paper with some following specific convention. For example, OH group lies on the right hand side, means it can be represented as D plus. So this can be called D plus isomer of glyceraldehyde. Are you able to follow? So this can be called D plus glyceraldehyde. Okay, and if it is a minus, means that is it is isomeric with OH on the left side, then it can be called, that is, L minus. Are you able to follow? So L and of course minus glyceraldehyde. Now let us move to the structure of glucose. Okay, let me rewrite this glyceraldehyde here. So what type it is? D type, is it not? So CHO, CH2OH. So how to call it? D plus glyceraldehyde. Now let us draw the structure of glucose. You know, this is CH2OH and this is CHO. In between that you have got 4 OH. 1, 2, 3, 4. So here H, OH, H, OH, that is the third carbon atom, and fourth carbon atom will be OH, H, and the fifth will be H, OH. These are all C, 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 C. These are all asymmetric carbon atoms. Okay. So when you look at this, you got the OH on the right side, and that is why we call it D plus, which is similar to this structure. For example, here you have OH on the right side. Similarly, I must write here H. Similarly, here you have OH on the right side. So this is classified as D plus. Are you able to follow? So this can be D plus glucose. You got it?